resolution of a vector is defined as finding the components of the vector. If we see here, this being x-axis, this being y-axis, this being origin, and our vector p, let this be 45 degree. Now if we draw a perpendicular here, O, A, B, in triangle OAB, this is a right angle triangle. So in this right angle triangle, let's take sine 45 degree, which is equal to P by H. So P means AB by hypotenuse, which is OB. Sine 45 degree is equal to AB. Let it be PY and this be PX. So AB is PY by OB, which is the magnitude of vector P. So Py is equal to P sine 45 degree, or in general Py is equal to P sine theta. Py is equal to P sine theta. If we take cos theta, which is equal to B by H, while base is OA and hypotenuse is OB. So cos theta is equal to OA. OA is Px, whereas OB is the magnitude of vector P itself. So Px is equal to P cos theta. So Px equal to P cos theta. Now we know Px is equal to P cos theta and Py equal to P sin theta. So this, if this is Px, this is also Px, because this and these sides are equal. If this is Py, this is also Py. Now if we see in the same triangle OAB, P is equal to, or P square is equal to Px square plus Py square, which is P square equal to P square cos square theta plus P square sin square theta. So P square is equal to P square. If we take this common, cos square theta plus sin square theta. So LHS is equal to RHS. So what is the most important concept here to take is this vector P acting at angle theta or 45 degree with respect to x-axis can be resolved into two components, one being x-axis in the direction of x-axis and another in the direction of y-axis, where Px is equal to P cos theta and Py equal to P sin theta. And these two components can combinedly give the same effect as the vector P itself. So vector P and the combined effect of Py and Px is same. So this is the physical meaning of resolution of a vector. In three-dimensional Cartesian coordinate system, this same vector P can be represented as P is equal to Px I plus Py j plus Pz k, where I, cap, j cap and k cap are the unit vectors. These are unit vectors in the direction of x-axis, y-axis and z-axis respectively. So this is I is unit vector in x-axis, j is unit vector in y-axis and k is unit vector in z-axis. So how do we find the rectangular component of a vector in two-dimensional coordinate system? Let us see. This is x-axis, this is y-axis, this is origin. Let P be any vector at an angle theta with x-axis. Let Px be axial component in x-axis and Py be vertical component. Now vector P can be written as Pxi plus Pyj cap, where I and j cap are the unit vectors along x-axis and along y-axis respectively. So I and j are the unit vectors which are perpendicular to each other on xy plane. Now if we draw a perpendicular on x-axis from this point, let it be C, this be A. So in triangle OAC, we know this is a right angle triangle, so sine theta is equal to P by H. Here P is AC and H is OC. So if this is PY, so if this is PX and PY, this is also PY and this is also PX. So AC is PY by OC. OC is the magnitude of the vector P. So P can be written as the magnitude of vector P. So Py is equal to P times sine theta. So Py can be written as P sine theta. Similarly, if we take triangle OAC again, and this time we take cos theta, which is equal to base by hypotenuse, base being OA and hypotenuse being OC. We know OA is Px, the horizontal component, and OC is the magnitude of the vector, that is P. So Px, the horizontal component, can be written as P cos theta. So the horizontal component is P cos theta, whereas the vertical component is P sine theta. Let it be D, this point be D. Then in rectangle OACD, in this rectangle, the horizontal component is Px and the vertical component is Py. This is Py, thereby this is also Py. This is Px, this is also Px. In this rectangular, the rectangular components are Px and Py in two-dimensional coordinate system. Now I'll try to find rectangular components of a vector in three-dimensional coordinate system. Let this be x-axis, this be y-axis and this be z-axis, whereas I be a vector, unit vector along x-axis, j cap is the unit vector along y-axis and k cap the unit vector along z-axis. Let us consider a vector P. So vector P can be written as P x I cap plus py j cap plus pz k cap, where px, py and pz are the components in x-axis, y-axis and z-axis respectively. So this is origin, this is our vector p. Let this be a, and we draw perpendicular b. So in triangle, let vector p makes angle alpha with x-axis. So in triangle OBA, this is a right angle triangle. Let cos alpha, which is b by h, here base is OB by h, hypotenuse which is OA. So OB, we know OB is px. This is the component of vector p in x-axis, that is px. And we know OA is the magnitude of the vector p, so it can be written as p. So px is equal to p cos alpha. Similarly, if alpha is the angle made by the vector with x-axis, beta is the angle made by vector p with y-axis, and gamma is the angle made by vector p with z-axis, then py is equal to p cos beta and pz is equal to p cos gamma. The magnitude of vector p can be written as px square plus py square plus pz square, or in two-dimensional coordinate system it can be written as px square plus py square. Similarly, if we know px, py and pz, that is, they are the components in x-axis, y-axis and z-axis, and if we know the magnitude of the vector, then we can find angle made by the vector with x-axis, y-axis and z-axis. So cos alpha will be equal to px by p, cos beta will be equal to py by p. Similarly, cos gamma will be equal to pz by p. In coordinate geometry, you will learn L square plus M square plus N square is equal to 1, where L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. So cos square alpha plus cos square beta plus cos square gamma will be equal to 1. As we know, magnitude of vector is equal to root under px square plus py square plus pz square, and we have already calculated px is equal to p cos alpha, py is equal to p cos beta and pz is equal to p cos gamma. So in this, px is equal to p square, so p square cos square alpha plus p square cos square beta plus p square cos square gamma. If we take p square common, cos square alpha plus cos square beta plus cos square gamma, and we know this is equal to 1, so it will be root under p square, which will be equal to p. So LHS will be equal to RHS. That's why these all equations hold true.